Hello everyone. Today we will discuss about the KNN, which is the K nearest algorithm. Remember, KNN is used for both the problem. So if you consider KNN, it can be used for classification problem, and also it will be used in the regression problem. Okay. And today we will try to explain the complete mathematical intuition of this algorithm. Okay, let's consider we have some data where we have multiple features f1, f2, and we have some output with 1 and 0. And right now I'm explaining the classification problem. Okay, so for classification problem, suppose we have data like this, and why I'm considering only two features, so that I can explain it into a two-dimensional plane. Actually, two dimension, I can easily explain it properly. Okay, so let's consider we have these data points. Let me take a different color probably, so that I can, let me put some different color. Yeah, so let's consider we have some data points which are part of 1 in something like this, and we have the different data points which is in this, like this. Okay, so remember it here. So probably all the green points are actually part of 0 classification, and all the orange colors are part of 1 classification. Okay, and let's consider this is actually my training data. So everything whatever here, it's actually training data. Now what will happen when for the logistic regression, when there will be a new data point. So for example, let's consider a new data point come into picture. Okay, so how logistic regression works, like when, if we consider from the stepwise point of view, when we have the new data point, first we have to identify a k value. And k is a hyperparameter. And in the practical example, we will show you like how to basically identify this hyperparameter using the grid search CV. But for the time being, let's consider k value is 3. And once we have this k value identified, then what will happen, it will check what are the 3 nearest point it has. So probably in this case it has this point probably nearer, this is probably nearer, and this is probably nearer. So that's mean from this perspective what is happening, so we have 2 orange is the nearer and 1 green is the nearer. So what will happen, this algorithm will say, okay, this new data point is actually part of 1. And how it is happening internally, it is basically calculating the distance. So it's calculating the distance. Okay, now how the distance is getting calculated, there are 2 ways it is calculating. One is Euclidean distance, and another is called Manhattan distance. Okay, now when we are calculating the Euclidean distance, what we are doing, we are simply, let's consider this is my x and y plane, and I have 2 points. Let's consider the first point is x1, y1, and probably the second point is x2, y2. So let's consider this point and this point. Okay, so we are calculating this distance. And what is the formula for this? The formula for this is x2 minus x1 whole square plus y2 minus y1 whole square. So this is the Euclidean formula, and based on that it is calculating this distance, and then out of these three nearest neighbors it's basically checking, okay, what is my classification. That's the way it's getting calculated. Regarding the Manhattan distance, it is getting calculated a little bit of different way. Suppose we have a point here. Suppose this is my x1, y1, and this is my x2, y2. In this case, it is basically calculating this, and sum of this is the total distance. So this is called the Manhattan distance formula, and this is the Euclidean distance formula. Okay, and accordingly, it is classifying that new data point, that okay, whether it will be class of 1 and 0. Remember, KNN is a very powerful and easy algorithm for even multi-class classification also. It just follows the same thing. Now, again, let me go back to the black pen probably. Now we'll discuss about the regression problem. Okay, so for regression problem, let's consider again probably just same thing like a house, square feet, and number of rooms in the house, and based on that we have to calculate the price. Now I think you all know that okay, the regression is basically when you have a target is kind of a continuous value. Okay, so price can be 10 million, 20 million, something like this. Okay, so what will happen, again the same scenario. If you probably have to do exact similar kind of thing. I'll just take different colors, so probably the orange color. So some of the data points are like this, and probably some other in a different color. So what we use green color. Okay, so some of the data points are again here, and that's everything by the training data. Okay, this is everything by the training data. And now you got a new value which you have to do the price calculation. So it will again check the k value. So let's consider k value is 3. It can be 5, it can be 6, it can be infinity. Okay, we have to choose the right k value. In this case, just for the demo purpose, I'm choosing the 3. So what are the 3 nearest neighbor? Probably it is looking like this, and maybe this, or maybe this, something like this. But what will happen, again it will check that Euclidean distance or Manhattan distance, and then it will select the 3 nearest point, and then what it will do, it will do the average of that. So this is important. So this is doing the average, and then it is getting the price. So that is the way, price. Okay, that is the way it is calculating the price for the regression problem. So this part we are talking about regression problem, and the left hand side we talked about the classification problem. Okay, great. I think it's clear. I'll try to give these things into my GitHub page so that it will be handy for you. By chance, if you are struggling to read my handwriting, let me know. I'll try to make it better. Now, another thing which is important, the limitation of this algorithm. This algorithm is very powerful, but few limitations, I will say, always try to remember these limitations actually when you will work on this. So this is important. This limitation part is important. Okay. First thing is, if your data is huge data, then it's a problem. Then do not use KNN. Okay, why? Because if your k value is very high, like if the k value is probably 100 or 50, something like this. Okay, so in that case you have to calculate the distance every time. Calculate the distance, so it will be slow. Okay, clear? So first disadvantage is clear. Now, what is the second disadvantage? The second disadvantage is, so the second disadvantage, it is very sensitive. So let me go back to that color so that it make more sense. So it is very sensitive to outlier. So this is very important. It is very sensitive to the outlier. And third is it is sensitive for missing values also. Very sensitive with missing values. Okay, now this outlier point is very important, so let me just quickly explain it. If I know we do not have the much space on the screen. Okay, let's understand this outlier point. Okay, and please remember this outlier point is very important. So outlier is very important. Okay, so what will happen, let's consider we have some data points like this, and we have some data points probably here, like this. But suppose we have some outliers which are actually falling somewhere here, and if you have a new test data which is probably falling here, then what will happen, it will consider this probably the nearest point, this probably the nearest point, and this probably the nearest point, but ultimately this is part of the green one. So it is very sensitive for outlier. Please remember this. So if you have an outlier, either you remove the outliers or do not go for the KNN. Hope you understand the complete KNN, which is K nearest algorithm. Remember it can be used for classification problem, it can be used for the regression problem. Whenever we are doing the classification problem, it's just selecting based on the K value, which is my hyperparameter. Based on the K value, it is selecting the nearest points and then taking the decision whether it will be 1 or 0 or it's multi-class classification, then it is taking that decision. All the calculations is happening by the distance. So the distance are either Euclidean distance or Manhattan distance. Euclidean distance formula is x2 minus x1 whole square plus y2 minus y1 whole square and then root over. So this is the Euclidean distance. When we are calculating the Manhattan distance, then we are basically calculating the side, the perpendicular side and the base side. So the total is coming the distance. And in this case, we are calculating the hypotenuse. That's a basic difference. For the regression problem, again, approach is same. Only thing at the end, like when you calculate the 3 nearest point, after that, we are doing the average. That's the important thing. And the limitation is huge data is the limitation, and outlier is very big limitation. So if you have a huge data, probably try some different algorithms, because in that case you might go for 500 or 100 and every time you have to calculate, so it's probably will be slow, but you can check the performance and then take a decision. But definitely if you have an outlier, remove the outliers, then work on it, or it will be very sensitive to outlier. Hope you like it. I'm able to explain it properly. Thank you so much. If you like it, please give a thumbs up or subscribe my channel. I'll see you in the next class, and that will be the practical example on KNN. Okay, bye everyone.